The question says, for a vibrating spring, its period T depends on tension F, its length L, and mass density, which is mass per unit length, sigma. If the relation is given by T is equal to K, F power X, where K is a dimensionless constant, use dimensional analysis to find X, Y, and Z. So we're going to find the values of X, Y, and Z by using dimensional analysis. We have the period, which is simply time, and in terms of dimensions, it is T. Then we have force, which is the tension force. Okay, which is equal to force is equal to mass times acceleration. In terms of dimensions, it is m L T to the power -2. So meters per second squared. Then this is capital M. Then what else are we given? We have this one L, which is length. In terms of dimensions, it is L. What else? We have this sigma, which is mass density, which is given by mass per unit length. So mass per unit length, which is simply mass over length, which is m over L. So from this point, we can plug in the values. Since this is a dimensionless constant, it does not have dimensions, and in dimensional analysis, we do not dwell so much on constants. So we can proceed as follows. We can say T is equal to, so F, we have, where there is F, we put MA, which is this one, the dimensions, M LT to the power -2. Everything to the power X. Then we have L, which is simply this one, raised to the power Y. Then sigma, which is this one. Okay, mass density, which is mL to the power -1. mL to the power -1 raised to the power Z. From this, we can now do some mathematics. Raised to the power 1 times 8, we have T, which is equal to M raised to the power 1 times X, it will be mx. L raised to the power 1 times X, it is X, to be T to the power -2x. Then we have L raised to the power 1 times Y, it is L to the power Y. Then this is M, so this is power 1 times Z, it is Z. Then L minus Z. Okay, let us proceed and see what we can do. Let's proceed. Some persons, we add the powers. So we can proceed by saying T is equal to, we have M, so we have, for M, we have X here. Then we have this one, which is Z plus Z. Then we go to L. L, we have X here. Then Y here. Then Z here, minus Z. Then we have T. So T here, it is just C alone on the right, so we have -2x. So from this, we know that this is raised to the power 1. Now, looking at the basic quantities that we have mass, we have length, and we have time. And on the left side, here we just have for T is the one that is raised to the power 1. So the rest, this is 0 and this is 0. So this must be equal to M X plus Z L X plus Y minus Z T minus 2x. So now, since we have these, if the bases are the same on both sides, so the left-hand side must be equal to right-hand side. So here for the powers, we have 0 for M, we have 0 is equal to x plus z. So x plus z is equal to 0. Let us call this as equation 1. For L, here on the left we have 0, which is equal to, on the right we have x plus y minus z. So x plus y minus z, this must give us 0. Let us call this equation 2. For t, we have 1 is equal to, on the right we have negative 2x. So negative 2x is equal to 1. Let us call this equation 3. Now to finish it up, we can just solve these equations simultaneously. And what we're going to get are the values for x, y, and z. So let us begin. So from equation number 3, we see that negative 2x is equal to 1. So this one, to find the value of x, we just divide by 1, negative 2, also here by negative 2. And x will be equal to negative. This is the value for x. Let us go to the next. Since we have the value of x, we can use the first equation to find the value of z. So we have x plus z. This is equal to 0. So we have x, which is negative half, plus z. This must give us 0. So when this comes or crosses the equal sign, we're going to have z is equal to, or z, this is the same as z minus half is equal to 0. So z is equal to positive half. So this is how it should be. Now the last one, from equation 3, since we have z and x, we can find, so we have x plus y minus z is equal to 0. Plugging in the values, we have for x is negative half plus y, so minus half. This would give us 0. So this is the same as y minus half, which would give us a 0. So here it is the same as, okay, y minus the common denominator here. The common denominator is 2. So 2 into 2 is 1 minus 1. So this one is going to give us 0. So y minus 2 over 2 is equal to 0. Y minus 1 is equal to 0. So y is equal to 1 as the value for z. So this is how the value for y, in fact the value for y is 1. So x is equal to negative 1 over 2, y is equal to 1, z is equal to half. So these are the values for x, y, and z. Thank you so much for watching the video.